The history of robotics dates back to ancient times, with early concepts of automated machines found in ancient Greek, Egyptian, and Chinese civilizations. One of the earliest known designs of a humanoid robot was created by the Greek mathematician Archytas of Tarentum in the 4th century BC. This wooden robot, known as the dove, was powered by steam and could reportedly fly. Fast forward to the 20th century, and the term robot was coined by Czech playwright Karel Čapek in his play R.U.R., Rossum's Universal Robots, in 1920. The play introduced the idea of artificial beings created to serve humans, setting the stage for the modern concept of robots. The first industrial robot, the Unimate, was developed by George Devil and Joseph Engelberger in the 1950s. Installed at a General Motors plant in 1961, the Unimate revolutionized manufacturing by performing tasks such as welding and material handling. This marked the beginning of robotics and industrial automation. As technology advanced, robots evolved from large, stationary machines to more agile and versatile systems. The introduction of sensors, actuators, and artificial intelligence enabled robots to perform complex tasks with precision and efficiency. Robots have been used in various industries, including automotive, electronics, healthcare, and agriculture. They have significantly improved productivity, quality, and safety in manufacturing processes. In the 21st century, robotics has expanded beyond industrial applications to include service robots, such as robotic vacuum cleaners, drones, and personal assistants like Amazon's Alexa and Apple's Siri. These robots are designed to assist humans in daily tasks, entertainment, and communication. The field of robotics continues to advance rapidly, with ongoing research in areas such as soft robotics, swarm robotics, and human-robot interaction. Ethical considerations surrounding the use of robots, such as privacy, job displacement, and autonomous decision-making, are also being actively discussed. Looking ahead, the future of robotics holds exciting possibilities, from autonomous vehicles and robotic surgery to space exploration and artificial companions. Robotics and automation are poised to transform industries and society, shaping the way we live and work in the years to come. Applications in production lines have been a driving force behind the adoption of robotics and automation in manufacturing. Robots are extensively used in production lines to perform repetitive and labor-intensive tasks with precision and efficiency. One of the key applications of robots in production lines is material handling. Robots equipped with grippers, suction cups, or magnetic arms can pick up, move, and place materials and components with speed and accuracy. This not only reduces the risk of injuries to human workers, but also increases the overall throughput of the production process. Another common application is welding, where robots are used to perform intricate welding tasks with consistency and quality. Industrial robots can weld various materials, such as steel, aluminum, and plastics, in a variety of configurations, including spot welding, arc welding, and laser welding. Painting is another area where robots excel in production lines. Automated painting systems use robots to apply paint or coatings to products with uniformity and precision, resulting in a flawless finish. This is particularly crucial in industries such as automotive and aerospace, where the quality of the paint job is essential for both aesthetics and protection. Assembly is a fundamental process in manufacturing, and robots play a vital role in assembling components and products on production lines. Collaborative robots, or cobots, work alongside human operators to perform assembly tasks that require dexterity and flexibility. These cobots are equipped with sensors and safety features to ensure safe interaction with humans. Quality control is paramount in manufacturing, and robots are increasingly being used for inspection and testing on production lines. Vision systems and sensors enable robots to detect defects, measure dimensions, and verify product quality with high accuracy and speed. This helps in reducing errors and ensuring that only products that meet quality standards are passed along the production line. In addition to these traditional applications, robots are also being deployed in additive manufacturing, commonly known as three-dimensional printing. Three-dimensional printers use robotic arms to build complex geometries layer by layer, allowing for rapid prototyping and customization of products. This technology is revolutionizing the way products are designed and manufactured, offering new possibilities for innovation and efficiency. Overall, the applications of robotics and automation in production lines continue to expand and evolve, driving advancements in manufacturing processes and reshaping the future of industry. Advancements in automation technology have revolutionized industries and transformed the way we work and live. One of the key advancements is the integration of artificial intelligence, AI, and machine learning algorithms in automation systems. These technologies enable machines to learn from data, adapt to changing conditions, and make decisions without human intervention. For example, AI-powered robots can analyze production data in real time to optimize processes, predict maintenance needs, and improve overall efficiency. The use of collaborative robots, or cobots, is another significant advancement in automation technology. Unlike traditional industrial robots that operate in isolation, cobots are designed to work alongside human workers in a shared workspace. These robots are equipped with sensors and safety features that allow them to collaborate with humans on tasks that require flexibility and dexterity. The rise of the Internet of Things, IoT, has also played a crucial role in advancing automation technology. IoT devices, such as sensors, actuators, and smart devices, are interconnected to collect and exchange data in real time. This connectivity enables seamless communication between machines, systems, and humans, leading to improved efficiency, productivity, and decision-making. Automation technology has also seen advancements in the field of robotics with the development of autonomous robots. These robots are capable of performing tasks independently without direct human control. For instance, autonomous drones are used for aerial surveillance, delivery services, and inspection tasks in industries such as agriculture, construction, and logistics. The adoption of cloud computing and edge computing has further enhanced automation technology by providing scalable storage, processing power, and connectivity for automation systems. Cloud-based automation platforms enable remote monitoring, control, and optimization of processes from anywhere in the world. Edge computing brings computing power closer to the devices and sensors at the network edge, reducing latency and enabling real-time decision-making. Overall, the advancements in automation technology are driving innovation, efficiency, and competitiveness across industries, paving the way for a more connected and automated future. The impact of robotics and automation on the workforce is a topic of significant debate and concern. While automation has led to increased efficiency and productivity in industries, it has also raised questions about job displacement and the future of work. According to a report by the World Economic Forum, automation is expected to displace around 75 million jobs by 2022, while creating 133 million new roles. This shift in the labor market will require workers to adapt to new skills and roles to remain competitive. Automation has also led to the creation of new job opportunities in fields such as robotics engineering, data analysis, and software development. However, there is a growing need for upskilling and reskilling programs to help workers transition to these emerging roles. Another aspect of the impact of automation on the workforce is the potential for increased job satisfaction and safety. Robots can perform dangerous and repetitive tasks, reducing the risk of workplace injuries and improving overall employee well-being. Additionally, automation can free up human workers to focus on more creative and strategic tasks that require critical thinking and problem-solving skills. Overall, while automation may lead to job displacement in some sectors, it also presents opportunities for innovation, growth, and a more dynamic workforce. The integration of robotics in daily life has become increasingly prevalent, with robots playing a significant role in various aspects of our everyday routines. One of the most common examples of this integration is in the field of household chores. Robotic vacuum cleaners, such as the popular Roomba, have become a staple in many homes, autonomously navigating through rooms to clean floors efficiently. These robots use sensors and algorithms to detect obstacles and adjust their cleaning patterns accordingly, making them a convenient and time-saving solution for busy households. Another area where robotics has made a significant impact is in the realm of personal assistance. Virtual assistants like Amazon's Alexa, Apple's Siri, and Google Assistant have become ubiquitous, helping users with tasks such as setting reminders, playing music, and providing information through voice commands. These AI-powered assistants leverage natural language processing and machine learning to understand and respond to user queries, making interactions more intuitive and seamless. Robotics has also found its way into the healthcare sector, with the development of robotic exoskeletons that assist individuals with mobility impairments. These wearable devices provide support and assistance to users, enabling them to walk, stand, and perform daily activities with greater ease and independence. Additionally, robotic surgery systems have revolutionized the field of medicine, allowing for minimally invasive procedures with enhanced precision and control. Surgeons can now perform complex surgeries with greater accuracy and reduced recovery times, thanks to robotic assistance. In the realm of entertainment and companionship, social robots have gained popularity as interactive and engaging companions for people of all ages. Robots like Pepper and Aibo are designed to interact with users, provide entertainment, and even offer emotional support in some cases. These robots use facial recognition, speech synthesis, and expressive movements to create a lifelike and engaging experience for users. Overall, the integration of robotics in daily life continues to expand, offering innovative solutions to enhance convenience, efficiency, and quality of life for individuals across various domains. One of the primary challenges associated with the integration of robotics and automation is the potential impact on employment. As automation technologies continue to advance, there is a concern that certain jobs may become obsolete, leading to job displacement and economic disruption. This shift in the labor market requires proactive measures to upskill and reskill workers to adapt to the changing demands of the workforce. Additionally, ethical considerations surrounding the use of robots in various industries have come to the forefront. Questions about data privacy, security, and accountability arise as robots become more autonomous and interconnected. For instance, in healthcare, the use of robotic systems for surgery raises concerns about patient safety, liability, and the ethical implications of delegating critical tasks to machines. Furthermore, the rise of autonomous vehicles poses ethical dilemmas related to decision-making in emergency situations, such as determining who is responsible in the event of an accident. Another challenge is the potential for bias in AI algorithms used in robotics, which can perpetuate existing inequalities and discrimination. Addressing these ethical considerations requires collaboration between policymakers, industry stakeholders, and ethicists to establish guidelines and regulations that ensure the responsible and ethical use of robotics and automation technologies. The future of robotics and automation is poised for exciting advancements and innovations that will shape industries and society in the years to come. One of the key trends in robotics is the development of collaborative robots, or cobots, that work alongside humans in shared workspaces. These cobots are designed to enhance productivity and safety by leveraging sensors and AI algorithms to interact with humans and perform tasks collaboratively. Another trend is the rise of autonomous robots in various sectors, such as autonomous vehicles, drones, and delivery robots. These robots are equipped with advanced sensors, navigation systems, and AI capabilities to operate independently in dynamic environments. In the field of healthcare, robotic exoskeletons are expected to become more prevalent, providing mobility assistance to individuals with disabilities and elderly populations. Additionally, the integration of robotics with augmented reality (AR) and virtual reality (VR) technologies is set to revolutionize training, maintenance, and remote operations in industries such as manufacturing and construction. As robotics and automation continue to evolve, there is a growing emphasis on human-robot collaboration, ethical considerations, and sustainability. The future holds immense potential for robotics to drive innovation, efficiency, and transformation across diverse sectors, paving the way for a more connected and automated world. In conclusion, robotics and automation have revolutionized industries and daily life, offering increased efficiency, safety, and innovation. From the early concepts of robots in ancient civilizations to the advanced AI-powered systems of today, the evolution of robotics has been remarkable. The integration of robots in production lines has optimized manufacturing processes, while the adoption of automation technology has led to new job opportunities and improved job satisfaction. Despite challenges such as job displacement and ethical considerations, the future of robotics holds promise, with trends like collaborative robots, autonomous systems, and human-robot interaction. As we navigate the complexities of a more automated world, it is essential to prioritize upskilling, ethical guidelines, and sustainable practices to ensure a harmonious coexistence between humans and machines.